Hello everyone! Today we're going to be learning how to solve logarithmic equations.
Yay!
Not supposed to be fun. It's work.
Oh, come on, Kirby. It'll be fun. Trust me, it's really easy as pie.
I just know I'm gonna regret this.
That's the spirit. Okay then, the first rule you have to know is that if you have an equation with two equal logs that have the same bases, of course, then their values inside the logs are also equal.
Wow. Well, what does that mean?
I don't know. What does that mean?
That means if you have a problem such as ln 7x minus 4 equal to ln 2x plus 11, you can just cancel out the ln's and just solve from there using basic algebra. So as you can see, the answer for this problem would be x equals 3. See, Kirby, that wasn't so bad.
How convenient.
Remarkable.
Yeah.
So let's look at this problem. Log 6, 3x minus 10 equal to log 6, 14 minus 5x. Like I said, these logs are both values of 6, so they're equal. That means you can just cross them out and just solve as normal. Now remember guys, you combine like terms. So you get 8x equal to 24, and then your answer will also be 3. Did you get that too, Toaster?
Yeah.
Well, then I'm sorry to say that you're wrong.
What?
The answer is really nothing. There are no solutions. Why? Because you've got to go back and make sure that the answers aren't extraneous, and this one is.
Well, how exactly would you propose we're going to do that exactly?
To check, you just plug your answer in as the variable in the original problem, like this. If you notice that 3 times 3 equals 9 and minus 10 equals negative 1. And so does this one. You can't have a log with a negative, so this answer is extraneous. Now guys, remember that you have to check for every problem that you do. In fact, let's go back to the first problem we did earlier, which is greater than 0. So 3 works for this problem. Now, from now on, just remember to check, okay? Always check.
Ow! What's wrong? He stepped on me.
Did not.
Did too.
Did not.
Did too.
Did not.
Guys, settle down already.
Hey, come on. How do you guys expect us to get there if you're fighting all the time?
Thank you, Toaster. Anyway, I've arranged an extra problem for you guys to try. Log 12x minus 11 equal to log 3x plus 13. What do you say, Lampy? What about you, Toaster?
I don't know.
Radio, do you have the answer for this problem?
Now look here, fellas, just give me a second and, whoa, listen to this. It's the top of the ninth, the bases are loaded, and Pee Wee Reese is at the plate. There's the pitch, and he connects. Oh, and it's a triple play.
Knock it off, you guys.
If you guys would just pay attention instead of fighting, then maybe you would have gotten the answer by now.
Oh, come on now, it's not your fault. Things could be worse, you know.
How?
How what?
How could they be worse?
They couldn't, I lied.
you guys had that problem written down because we'll discuss it tomorrow and hopefully one of you has that figured out by then. Anyway, let's look at this problem. Log 2x minus 6 equals 5. If you notice, there's a log on just one side. How do we solve it? We just give this log a base of 2 so it'll automatically cancel out, like this. But don't forget your algebra rules. Whatever you do to one side, you have to do to the other to keep the equation equal. You have to give the 5 a base of 2 as well. And don't forget that 2 to the 5th power equals 32. So now your new equation will look like this. Now it gets easy. You just add 6 to 32. And what did you guys get? 38? Yep, that's right. Now, like I said before, don't forget to make sure it's not extraneous. But it looks like 38 works for this problem, so that's our answer.
That's very interesting.
I know, right? That wasn't so bad. Now how about trying a similar problem yourselves? Try log 4x equals negative 1. Heads up, the answer isn't whole. It's actually a decimal, or a fraction if you want to make it that way. But that's because it's a negative 1. So just be aware of that. And good luck.
I think I know what you're talking about. You know something? You're a real bright little lamp.
Oh, thanks. Hey.
Good job, guys. Now for the last part. What if you have a logarithmic equation that has an operation in it? You can't just cancel out. You have to condense it first. An example will be this problem. Log 4x plus 12 plus log 4x equals 3. You have to have one log on one side of the equation. How do we get there? We just use our condensing rules and multiply the inside values to get rid of the extra log. Now we can solve the problem as normal. Remember what the first step is? You gotta give both sides a base of 4 so that the log cancels out. And apparently it equals 64. Bring the 64 over, and you just factor. So then, your x's are negative 16 and positive 4. But we can't forget to check for any extra answers, and when you plug them back in, it looks like negative 16 does not fit, so 4 is your answer.
Boy, I'm glad we don't have to do this every day.
Don't worry, guys, we're almost done. Just do me a favor and try this problem on your own. Log 6 3x plus log 6 x minus 3 equals 3. It's not too hard. Okay, everyone done? We'll discuss more about it tomorrow. And this concludes our lesson for today. See you guys later.
We did good, didn't we? Yep. We did good.
You're all a bunch of junk.